Okay, physics students, wanted to run through some answers to the Ohm's law and power practice questions for you. First question, when you turn on the water faucet, water usually flows immediately. You don't have to wait for the water. Why not? Well, there's a simple reason. And the reason is that the water is already, can't spell, in the pipes. So the water is under pressure, and that pressure is what pushes the water out of the faucet. There's literally just a barrier. You turn the valve and there's something that cuts the water off. And so the analogy here is that just like water is already in the pipes, you've got charge already in the wires, and it's already everywhere in the wires. And so what makes the charge move is the battery, the power supply, ultimately the voltage, the oomph, the push. So when you connect up the battery, you are pushing the charge that already exists. So that's why you don't have to wait any length of time for the light bulb to light up. The battery, as soon as there's a complete conducting path between positive and negative end, charge begins to move. Number two, is current used up in a resistor? Well, we've done a couple of labs where we've measured current in different spots, and the current was always the same. So I would say that no, current is not used up in a resistor, because if it was used up, then we would see different values of current in different parts of the circuit, but we don't. We see different, we see same current no matter what. All right, now we start getting into some problems. So I'm giving you a resistance of 3,300 ohms. I'm giving you a voltage of 6 volts. And so if I want to find current, we go to the fact that Ohm's law, I, current, is equal to voltage over resistance. And so all I have to do is I is equal to 6 volts over 3,300 ohms. And so that, I have to get out my handy dandy calculator for, which will take me a second, is a pretty small number. And the answer should be at the bottom of the second piece of paper, 6 divided by 3,300. And that's getting me something on the order of 0.0018. And I think if I sneak a peek here, yep, 0.0018 looks like a good answer to me. And it's current, so it's measured in amps. Okay, now number 4 starts looking at some voltage, some power types of questions. So if we want to find the resistance of the toaster, the key is to just start with what you know. You know that the current is 4 amps and that the voltage is 120 volts. And so if I know that I equals V over R, I could rearrange that and figure out that R is equal to V over I. So I've got 120 volts over 4 amps. And if I'm doing that right, that's going to be a 30 ohm resistor. And then if we want to, we can figure out how much energy it takes. So energy is related to power. So let's go ahead and remember that power is the amount of energy per second. And we also know from the little class time video that was posted on Monday, April 27th, from an electrical standpoint, power is equal to voltage times current. So if I have a voltage and a current, I can find the power. 120 volts times 4 amps, and that's going to be 480 watts. And then I could say, hang on, if I know 480 watts, I know the power. And I want to figure out how much energy it is in 30 seconds. Remember that this time is always in seconds. I can figure out the amount of energy by just doing that math. I can't spell today, NNG. So I do 480 times 30, and I throw that into my calculator. And that's 14,400, and we remember that energy is measured in joules. Okay, let's scoot this up a little bit. So 100 ohm resistor, So I've got a resistance and I've got a current. Let's find the voltage. Taking I equals V over R and just rearranging it, V equals IR. And so voltage is equal to 3 amps times 100 ohms. And I'm going to put the units in here, just got a little sloppy. 3 times 100 is 300, and then voltage is the units V. Okay, now a little bit tricky here. This is a kiloohm. So when you're dry, your resistance is 500,000 ohms. That's a pretty high resistance. But if you get wet, your resistance goes down dramatically. Now I'm only 100 ohm resistance. So when I stick my finger in a socket, which is a terrible idea, all right, and I want to know how much current goes through me when I'm dry, what comes out of our electrical sockets in the house is 120 volts. If I'm dry and I have a really high resistance, how much current is that going to be? Well, 120 divided by 500,000. That is a minuscule amount of current. Compare that to when you're wet. 120 volts divided by 100 ohms. And that is so much larger. In fact, it's so much larger that that would be quite dangerous to you, especially if it went across your heart. So bad, bad, bad to mess around with electricity when you're wet because your resistance goes down dramatically. All right, a couple more problems here, and then that will take care of you. So if I look at this and I'm trying to find power, keep in mind that power is voltage times current. So in this case, I know the voltage. What I don't know is the current. So I'm going to do a little bit of work to get current. I equals V over R, 8 volts divided by 5 ohms. That's 1.6 amps. And so the power is going to be voltage times current, 8 volts times 1.6 amps. And if I do that, and I lost my calculator, let me get that back on the screen. 12.8 watts. Yep, and then we get to the other one. And same deal, except this time I already have the voltage and the current. And so if I just want to find power, I can just go straight to it. P equals VI. And I've got a voltage of 18 and a current of 0.3. 18 times 0.3. Throw that in your calculator. And if I'm reading this right, 5.4 watts. All right, and it says, assuming that the resistors are light bulbs, which one would be brighter? Well, which one's using more energy per second? This one's using 12.8 joules per second because that's what a watt is. This one is using 5.4 joules per second. That's what a watt is. So clearly, this one is going to be brighter than this one. This one is going to be dimmer because 12.8 watts is more energy per second than 5.4 watts. All right, and we're going to the last problem here. So I've got a 75 watt light bulb, so I know the power is 75 watts. I know that power is voltage times current, so I've got 120 volts times current. So I can find the amount of current, but that's not quite what the problem's asking me for. But you know, with these electrical problems, as I encounter information, I just like to figure stuff out so that I know it. So the current through this circuit is 0.625 amps. And so this one's asking me for resistance. I equals V over R. If I rearrange that for R is equal to V over I. And so my resistance is going to be my 120 volts divided by 0.625 amps. And if I do that, 120 divided by 0.625 I think that's 192 ohms. And I've already found the current as 0.625. So hopefully me running through that with you is useful, and enjoy. You guys have a great day, and keep learning. I'll see you again soon. Okay, bye-bye.